Hi, it's Dr. Taft, and I'm going to talk about the first part of the basics of probability, random processes. So before we can talk about a random process, let's talk about what we mean by process when we're talking about stats. So as you can see in this text-heavy slide, what a process is it's kind of like a machine. It's an imaginary idea that there's stuff that we don't know exactly what's happening, but every time the machine operates, there's an observable result. So Adam Smith, the famous economist, came up with the term invisible hand to talk about how the market could achieve things without us being able to directly observe it. So the key thing about processes in stats is that we're not able to observe what they're doing. We're only able to observe the results of their actions. And what we call one of those results is an outcome. And each operation of the process could be called a trial, or an event, or an experiment. I typically use the word trial in this course. Depending on the kind of stats you've taken, you might hear the word event or experiment. So I often think of it as it's like a classic black box machine where you pull a lever, there's some noise and stuff, and then boom, out comes an outcome. And it's not, get it, out comes an outcome. I didn't even do that purpose. So that is what we call process. And then a random process has some unpredictability to the outcomes that result. So that's to say, you pull the lever and you don't know exactly what you're going to get. Like a bubblegum machine. Put a quarter in, twist the thing. You might get a red bubblegum, you might get a white bubblegum, you might get no bubblegum. You don't know for sure. The individual outcomes are not predictable. But if there's whole collections of them, then, so like if the bubblegum just has red and white bubblegum balls in it, and you know that you're never going to get a blue one, but you might get a red or you might get a white. And whether you're more likely to get a red or white one depends on how many of each color there are there. And that's what probability is about studying. So different kinds of random processes can be think of as different machines that produce different patterns. So if you roll a bunch of dice and add the numbers that are on top up, you get different combinations of results, and some results are more likely than others. Dealing a hand of cards is a different random process than spinning a wheel or pulling a lever on a slot machine. Each of these different kinds of random processes produce different kinds of patterns. And so we can learn about the process by investigating the pattern, or we can predict the patterns based on the material properties of the process. So a pattern is a real-world phenomenon made of many observations. And so you can have one process, or you can have a series of processes in a row, like dealing a deck of cards out. It's actually multiple random processes. There are going to be some non-random parts. So, for example, the bubblegum machine, we know we're going to get a piece of bubblegum. That's not random. They're all going to weigh about the same. They're going to have roughly the same texture. But the random parts, what color it is and maybe what flavor, that will be different for each observation. And so we can characterize the processes that we see by the patterns they produce. So I'm going to talk about 3 examples of that. First one is the Bernoulli process, named after Jacob Bernoulli. And that is the process when there are only 2 possible outcomes. The classic example of that is a fair coin toss, heads or tails. Only options available. But the 2 outcomes don't have to be equally likely. So fair coin toss, both outcomes are equally likely, but in a game between the Globetrotters and the Generals, there's only one outcome that's ever going to happen. The Generals ain't going to win. And so that would be a Bernoulli process with probability of Globetrotters winning that's high and the Generals winning low. And a football or a hockey game is not a Bernoulli process because there are 3 possible outcomes: win, lose, or tie. So if there's a draw, that's the 3rd possible outcome, so it's not a Bernoulli process. Another kind of process that is commonly known as a Poisson process, named after Joseph Poisson. And a Poisson process is a count of how often or how frequently a rare outcome occurs. So this happens classically in the spatial distribution of uncommon things like rare plants or geological deposits, like if you're looking for oil. So you put a grid down and you count how many times the thing you're looking for occurs in each grid cell. Most of the grid cells are empty, but a couple of them have one thing in it, and then by chance this one has two. So this would be a Poisson distribution with 11 zeros, 3 ones, and 1, 2, a single 2. And so empty spaces in each row in our garage. Empty spaces are pretty rare. How many times you get shared by a tag gets shared by an influencer, or how many people are in line at Starbucks. Most of the time it's empty, and then a few times there's like a million people in line, especially right outside my classroom. So then a Gaussian process is what happens when there are many small influences summed into a single observation. So things like height, weight, shoe size. I need to change the comma on that. Physical phenomena like the dimensions of manufactured goods, size of stones and concrete, economic things like prices and inventories. Many, many, many things in real life can be modeled or considered to be the result of the adding together of many small random effects. And so that turns out to be the most important kind of random process. It's the sum of many small random processes. So we're going to look a lot at Gaussian things. So that is it for the first part of the basics of probability, random processes.